Hi, everyone. Thank you for joining us. We have Jeff Giuliani here today conducting a training on hose surveys. He will be identifying industrial hose issues and providing solutions. If you have any questions during the webinar, please use the question feature, and we'll go over all of your questions and comments during the wrap-up section at the end. So without further ado, I'll pass it over to Jeff.
Good afternoon, everyone. Thanks for joining us today for our hose survey webinar. My name is Jeff Giuliani. I am Regional Sales Manager for the Ideal Tridon Group, Northeast. My territory is the Northeast and half of Canada. A couple questions I'm sure you're wondering. My last name is Giuliani. I am not related to Rudy. And the Jersey Shore people, I don't know them, but probably 85% of our citizens act just like that. But coming to you from the great state of New Jersey. So today we're going to talk about hose surveys, identifying industrial hose issues and providing solutions. Our agenda, we're going to discuss crimpnology. Why is this instrumental in conducting a hose survey, how you use it? Why does an end user need a hose survey? Two of the typical reasons are a customer's request after they have an incident or an accident. And then it's definitely something that you can offer as a value-added service. You can help write a spec sheet, keep track of the hoses, etc. We're going to get into NAHAD's best practices and recommendations and their common rules for fittings and applications and some really good guidelines to follow. We're going to have some in-the-field pictures identifying some common problems and how we can improve process safety. And also some pictures of some common field mistakes, and then a conclusion with question and answer, and we're going to have a little poll at the end. So jumping right in. So everyone should be pretty familiar with stamp data. So this is pretty much the big first step into a hose survey. So when you're on site or when you're proposing a hose survey, this is the types of things you want to be thinking about: the size, temperature, application, material, pressure, ends, and delivery. And what that entails is the size. You're thinking the ID and the OD of the hose. When it comes to Campbell fittings, we are very interested in the hose wall of the hose. That's part of our crimp procedure. Temperature, the temperature range of the material flowing through the hose, and in some cases, most importantly, the environment around the hose, especially if it's a elevated temperature environment. That's very important to factor in. The application, of course, how is it being used? Is it pressure, vacuum, gravity application? These are all important factors we need to know. The material, what's going through the hose, being specific is very critical. Need to be aware of chemical compatibility, things like that. For the pressure, maximum pressure including surges, and what the hose assembly will be subject to. This is pretty important. We're going to jump into this in a second when it comes to using crimpnology and dealing with pressure ratings. The ends, that's what coupling they're asking for. What are they using? This is a good part of the hose survey too, is sometimes there will be fittings that are being used in the wrong application. And, you can be using a lesser fitting or, a better fitting for a critical application. This all comes into play. Then, of course, delivery. They don't need anything special for their delivery. Oh, one second. Sorry about that. So Campbell crimpnology. So Campbell has developed a system for crimping industrial hoses with our fittings. Basically, been testing, engineering, coming up with these crimp specs and procedures for about 20 years now. And basically, it is the technology of crimping and creating superior hose systems. So when you use a Campbell fitting with its ferrular sleeve, you're getting a guaranteed result. Some general crimping do's and don'ts. There are 4 essential elements to a properly crimped hose system: the 360-degree ferrule interlock, having appropriate serrations, matching the shank with the length of the ferrule under sleeve, and then detailed assembly procedures. So the picture on the top left for the 360 ferrule interlock. It's important when you're using a ferrule as opposed to a sleeve, you need to have that groove for the ferrule, the teeth at the end of the ferrule to interlock with. Very important in our crimping procedure. And if you look on the picture on the right, you have a ferrule with going onto a fitting without a groove. And then that little fitting, the little picture on the right, it's not even lined up with the ferrule groove. So that's the wrong ferrule for that shank. So it's important to have the parts integrating with each other. And that ties in with the appropriate serrations. If you notice on the left, the Campbell shank has the max amount of serrations on that shank. And we utilize all of them for hose retention. Whereas the picture on the right is your typical bump shank designed for a sleeve or really designed for clamps. Although you will see some distributors putting ferrules on these shanks, like the picture right below it actually. And then matching the ferrule and the sleeve length is very critical to have your ferrule interlock with the groove, along as having the shank line up with all of the serrations. Where that picture on the bottom right, there's a lot of space missing where you're going to have some premature hose wear, and this is going to damage your hose and create a leak path much sooner than typically would happen. Detailed assembly procedures. All of our Campbell Fittings distributors will have on-site crimp trainings, so everyone that's putting these hoses together will learn the proper procedure. And this gives you a better picture of the wrong way and the right way. Again, you have a too short of a ferrule, it looks like on the left here, where when that hose is being bent over, perhaps it's going to really damage the interior of that hose. Where you have the Campbell shank on the right with the ferrule and lining up exactly with the shank length. Improving process safety. This is a nice kind of buzzword that most end users like to hear. They're all about value added and improving their process safety. And so one of the ways you can do that is to start crimping most of these hoses, especially in the critical applications. Campbell actually rates all of our fittings and how they're attached, whether it's a sleeve or with a ferrule. And as you see on the left, all of our fittings, again, are rated. And then the bottom right gives you a little sample of the crimp procedure and how we put the fittings together. How we get all of our numbers, tons and tons and tons of hydrostatic testing. On the right, that gives you a little example of one of our hose tests, which we're happy to provide for you, for your end user, whoever wants to see it. And then on the left gives you a sample of a mini test report going certain fitting by fitting what their test report was, a mini version of it. So Crimpnology, 20 plus years of research and testing in each spec. All of our testing is done to ASTM D380 standard with an RMA safety factor application of 3, 4, 5, and 10 times. So 10 times will be for steam application. 3 times is typically for a low pressure 150 PSI water application. For the most part, everything that was in the previous slide is typically a 4-to-1 safety factor. It's pretty much the standard for most of our fittings. Crimp specs are pre-calculated, provided for every hose, regardless of manufacturer. So as far as the hose is concerned, we've tested them all. So we don't mind what hose you're using, other than steam applications, which are specific to 3 manufacturers. Proven crimp specs, lab tested, field certified. Like I said, we test and test and test. And these are pressure ratings, not recommendations. We're standing behind it. You follow our procedures, use our specs, we're guaranteeing performance. NAHAD, I'm sure we're all part of NAHAD, which is kind of sets all the guidelines and oversees the industry, specifically the Hose Safety Institute. These are NAHAD members who agree to fabricate hose assemblies in compliance with the guidelines. And I'm going to show some sample guidelines from NAHAD for fittings and some applications. and starting with cam and groove. So cam and groove is pretty much, I'm sure everyone's familiar with. This is just about everywhere out in the field. There's not many kind of warnings, except the big one at the top. Cam and groove couplings must never be used for compressed gas or steam service. That's very critical. And you will see that out in the field. And then the second part of replacement of cam arms, if it has to be done, you should only use the original manufacturer's arms. And then when you do clamp a cam and groove fitting, when you space the clamps, the buckles need to be on opposite ends, rotate 100 degrees from each other. When you have the buckles all on the same side, it can increase the pressure on that side of the hose and create a premature leak path. And we're going to get into some field pictures. So here is a Campbell Cobra fitting with a broken arm. And it looks like there is one clamp on there that is spray painted yellow. But this is typical. A lot of broken arms you'll see out there. Line dedication, I'm assuming that they're spray painting their yellow hoses for a certain application, which is good on one hand, bad on the other if the fittings are falling apart. This is another problem. So the buckles here are not offset. So you would want to have them on opposite sides of the hose, not right next to each other. And then with these worm gear type clamps, you have them sticking out, probably sharp ends there. It's not going to be easy for the operator to handle. And again, this is whether you've been with had a hose survey before or not. These are some of kind of the easy things you can pick up on right away. And there's also, looks like a missing arm there too. Here we have another, looks like tape around the hose. I don't see any clamps. We have a rusted fitting as well, same thing. There's some sort of tape keeping this hose together. I'm not even sure how it's staying in service. Here we have duct tape holding down the arms. So duct tape, everyone's friend, right? Solves every problem. You'll hear a lot of end users say, oh, I don't want to have anything crimped. I need to field repair it. What happens at 2 in the morning? Well, it doesn't matter what happens at 2 in the morning in this case, because this is broad daylight and there's duct tape on a hose. So they had plenty of time to fix this and decided not to. So when they talk about field repair and how important they didn't want downtime and this and that, this is something that, it's something to show them that, all right, well, you have duct tape on this. How critical is it? Here we have another buckles not offset, broken handle. So now jumping into universal couplings, Chicago fittings, crow's foot, pretty typical for air and water service. The big highlight there is a locking pin is placed in the holes to provide a safe connection. And the big warning is safety pins, clips, wires should always be installed in these couplings. And the universal fitting should never be used in steam service. So that's our first 2 fittings, cam and groove, universal coupling, not to be used in steam service. So now we have a universal fitting. It's on a redwater hose. The drop is a horizontal drop, so the hose has a little bit of a kink to the end, kink bend to it. So it's not really doing that hose any favors in terms of service. The hose is crimped, which is fine, except it still needs to be pinned. Here's another Chicago universal fitting. No locking pin. You have 1 clamp. You need to have 2 clamps for any of these assemblies. There needs to be at least 2 clamps on a hose. This is slowly ejecting from the hose and obviously is not long for service. And here's another kind of a typical hookup here. You have a really tough bend on that hose. You have a banded hose and you have no locking pin. So at this point, if you're walking around this plant and you're with the maintenance manager or whoever it may be, now comes a discussion of, okay, you don't have any pins in your fittings. I can help you with that. And typically, you're not going to see a lot of pins. Usually they're along the ground, or they're in a drawer in the storeroom, or they're in someone's pocket just in case there's inspection. They don't really have these pins in the hoses. In fact, I've only seen pins in a Chicago Universal fitting once, and I was stunned, and I asked why, and basically said, oh, we got fined last month. So that's when you'll find pins. So how do you combat no pins? Well, Campbell has what's called a Universalock coupling. So this is OSHA compliant without the pins, and those fines can be up to $800. It's a self-locking sleeve, and also, if pressure is an issue, you can get up to 300 psi if you're hooking up a Universalock by a Universalock. And we have a male, female, and a hose end. Also, one thing to keep in mind, our universal fitting, the third one down, attached with a ferrule and an air hose, rated to 150 psi, which is standard, except that we've tested it and we'll provide a test report. But the Universalock, the top, that's rated to 300 psi. This is actually a video of my Universalock sample out in the field, meatpacking plant, and we walked by this drop, and just to show you how easy it is to hook up and how it locks on. So you push it on, sleeve locks on, then you retract the sleeve and turn to disengage. By the way, all this, of course, will be recorded and is available, and I can email any of these slides if anyone needs it. Bose and Thor fitting, another air type fitting. That top one on the green hose, the Bose single lock fitting. The one beneath it is called a Thor double lock fitting. General uses low pressure air and water. There's some limitations with volatile fluids, but the one thing to keep in mind is that the Campbell fittings, Bose and Thor, again, is rated to 300 psi. This shows you a Thor fitting. The buckles are not staggered, and it's beginning to pull out of the hose. So you're not really getting the hose retention that you need here. And that fitting kind of looks a little on the rusty side too. Same with this Bose fitting, one band clamp attaching this Bose fitting. Buckles are not offset. One thing to keep in mind too, you'll see quite a bit of bubble crimps, at least I have in the past. You'll see quite a lot of bubble crimps. So the left bubble crimp is on a steam fitting. You have a Thor fitting top right and then another steam at the bottom. This is basically an old style crimp procedure that is still kind of perpetuated to this day. Basically, when I see this, what I think of is that whoever put this hose together really had no idea how to crimp in 2020. Like I said, just an old style. You don't get less retention. If you think back to the picture of the Campbell fitting with the serrations, Campbell fitting serrations are not cosmetic. We're using them all for retention. So this was a way to let that hose grow so they wouldn't crimp the whole ferrule and you'd have a little bit of hose growth. And this, they thought, I don't know, kept the hose on better for some reason. But again, this is definitely something to sell against. This is being supplied by a distributor with no procedure or just old procedure. Here's a sample test report for the Bose fitting. We also make a yellow ring that specifies, it says for nitrogen use only. So one of the things you want to get into is line dedication with an end user. If they're using a universal fitting on everything, it could lead to problems with crossing the lines. So we have this yellow ring that we want to hopefully specify for nitrogen service. So it doesn't matter if the hose is blue, green, yellow, whatever. You just know that the nitrogen is going to be hooked up with a Bose fitting, for instance, or a Thor. And at the top of that picture, that second hose down in green, there's a black ring. So That doesn't say for industrial use, but it's kind of just like a plain ring that you can also have as well. Improving process safety, again, with the test report. One thing to also keep in mind, those rusty-looking Thor and Bose fittings, Campbell makes our sleeve with a ZA zinc aluminum that's non-corrosive. So those fittings can be tough to deal with from the beginning, but with a Campbell, it's really good for the life of its service. And so once you're in service, you're not going to have that rusting if you see that top right picture from the air hose couplings. Ground joints. So this is another kind of granddaddy fitting like the Cam and Groove. You'll see these. These are used for high pressure air, water, steam. These are kind of used for almost every application. Few differences. So Campbell Fittings makes a ground joint, but ours is designed and engineered to be crimped with a ferrule. So you'll see that 360-degree interlock, the aggressive serration pattern. We have a little bump that helps with the tube wear, whereas the style on the left is cast shank, designed to be clamped, although I've seen this crimped many times with ferrules out in the field. And then when you're putting together a ground joint, you would want to use one of these types of clamps, an interlocking clamp. The highlight here, so the one at the top right, that's the Campbell Fitting U-bolt interlocking clamp. The limitations here, these are designed to use with fittings. They are not designed to use with fittings without an interlocking collar. So you're going to need to hook on to the fitting and then before you start clamping it. The big thing here is, for the warnings, the retightening of clamps is necessary before each use. Now, anyone who has been out in the field knows that retorquing of bolts basically never happens. I'm not even sure it happens when the hose is initially put into service. But this is a big thing to harp on, especially when you get into a steam type fitting and crimping it. The picture on the left shows you how the clamp impression after an old style clamp is put on there. Where the U-bolt also is a 3-piece clamp. It has a shell, a casting, and then the bolts. And all of the bolts of the U-bolt are on one side. So if by some miracle they are retorquing the bolts, it's going to be a little bit easier because all the bolts are on one side. Maybe they will be more likely to do it at that point. And this is kind of the cut sheet for improving process safety for the big air, and you have your ICU bolt clamp. Steam hose. This is where the difference for Campbell is that you can't use any steam hose on the market for a Campbell fitting. It's only designed for certain steam hose manufacturers. The one highlight here is that hoses, should always be drained after use and prior to storage. So when you are walking around doing a hose survey and you see hoses all over the ground, right away, there's something to bring up. Those hoses should be hung up. They should be in racks, not necessarily steam hoses, all hoses. I mean, it's basically a tripping hazard. But these are the little things to highlight in your hose survey. When it comes to steam needs a 10-to-1 safety factor. Also, all hoses need to be statically grounded, but steam can get very dangerous when it acquires a charge, very dangerous to the operator. And the way the Campbell steam fitting is designed, if you notice the little kind of teeth on either side of that, they will bite to the wire of that steam hose, and that steam hose is electrically conductive as soon as it was crimped. And then a big warning here, when utilizing the crimp method to fabricate steam hose assemblies, manufacturer crimp specifications must be used. When a Campbell Fittings steam fitting is only for authorized distributors, so that means that they only have access to that fitting and they will have an on-site training in how to put it together. Here's some typical steam issues out there. Kind of a rusted spud, and then you have a missing bolt. So I don't think they're retorquing these bolts. We have another missing bolt, corroded fitting, making it difficult to retorque this clamp. Steam hoses should be drained and retorqued after every use, and torque values under 25 foot-pounds are considered unsafe and potentially hazardous. Again, no one is retorquing these bolts. It's a great thing to keep in mind when you're trying to convert to a crimp. There's a missing bolt. This steam hose, damaged and cut, O-ring damaged. Again, these are not, you don't have to be a seasoned pro to figure out these issues when you're doing a survey. These jump right out at you. Steam hose connected with a straight pipe. You're just adding potential leak paths at the threads. Here's a Campbell fitting steam hose. It's crimped, but you do have a cut in this hose. It's been in service too long. This is one of those, everybody wants to field repair hoses and save hoses and repurpose them. In some cases it's fine. If you cut off an end and re-crimp a fitting on there or clamp it and proof test it, it's fine to put back into service. But a lot of times these hoses just pile up in the yard. They never get repaired. They never do anything with them. Proving process safety with the steam hose couplings and hydrocarbon drain. Hydrocarbon drain is on here because it's, especially in the refineries, it's basically a sister application to the steam. Unfortunately, it gets crossed quite a bit. So you'll see steam hose in a hydrocarbon drain application and vice versa. Again, the Campbell fitting bite-to-the-wire ferrule reduces dangerous electrostatic discharges. No need to retighten bolts. So all of the Campbell fittings ground joints are a hand-tight fitting. So not only do you have to retorque bolts, but you go right up and you just thread these right on, hand-tight, and you're good to go. You walk away. This shows an old-style plastic seat ground joint coupling on the left, and where you have the Campbell Viton Seal ground joint, metal-to-metal seal, eliminating all potential leak paths. And this is the big, one of the huge factors in steam. It costs a lot of money when you lose steam. You got 2.6 pounds steam is hissed away per minute. That's $11 for 1,000 pounds of steam. $41 for 1 day. That's $287. The cost of that coupling leaking for a week. They're paid for your steam hose right there. $1,250 for the month, and at a typical 5-month steam season, that's $6,200 each end is losing. So whether it's the maintenance guy or purchasing, there's a story to tell here. And this is another factor. So when you have that leaking steam fitting, it's going to create a puddle. And this is a rail car, so I don't know if there'd be any walking hazards here, but if this was on just the regular grounds and you head up north, this becomes an ice puddle that's pretty large that would become a very dangerous slip hazard. And hydrocarbon drain, so it's one of Campbell's ground joints. It's hand tight. It has a yellow chromate plating and different threading. So again, line dedication, you don't want to be mixing and matching your hydrocarbon drain fittings or hoses. This is a hydrocarbon drain hose that was using a hydraulic fitting with a union. So again, not the best hookup here. And this was plant specific. This was one plant that had 4 different hoses in a hydrocarbon drain application. Some were being used in steam service. Again, this is just that kind of casual nature that everyone may have. Once they're running and gunning, they just grab a hose and put it on. They don't really take the time to say, hold on, is this the right hose? Is this the right fitting? Where if you had a line dedicated different fitting on there, they couldn't even hook it up. They couldn't get started. So there's many common hose practices that lead to serious hose failures. How many people have heard this? How we've always done it. We've never had a failure. I've heard it quite a bit. But there's still things that they're doing out there that cause issues. Here's an over-crimped hose. This will lead to tube damage, leaks, fitting ejections. You can plainly see that this was way over-crimped. Actually, looks like it's a Campbell ferrule, but they didn't follow our procedure properly, and this hose should never have been put into service. Here we have an unknown hose. The bad crimp, that fitting is cocked to the side. So this is somebody that probably forgot their bubble crimp, actually. But this is not following, if this was a Campbell fitting, they weren't following our procedure properly. You do need to allow some room for that hose to grow. So part of our procedures, one of the things we do is we only insert the hose up until the laceration of the fitting, but that's just a procedure issue. But this wasn't followed. Here we have a garden hose style fitting. One band, hose is kinked. Also part of the hose survey is visual inspections of the hoses. So what are you looking for? Abrasions, cuts, tears, kinking, discoloration. Not all of these are necessarily factors to pull a hose out of service, but they're mostly factors to re-examine the hose, maybe proof test it again, recertify it. But in some cases, you'll see it can get very bad. Here's a few field pictures of damaged hoses still in service. Pretty self-explanatory. Most of these cracked, run over, helical wire busting through the hose, cut hose, reinforcements showing with no cover on the bottom right one. Same thing here, pretty easy to spot. These hoses are kinked and stressed, and sometimes an end user might be wary of allowing a hose survey because they just think you just want to sell some more hoses. You're not worried about safety. Now, of course, you want to sell some more hoses, but if they have their hoses set up like this, well, you're already making the life of these hoses. You're shortening the life of these hoses dramatically. Here we have exposed wire seen through the cover, most likely exposed to chemicals externally and severe abrasion from being dragged all around the plant. This one, so the right picture, so that's a crimped end, and then on the left picture, the bottom right of the left picture, we have a clamped end. So these hoses are hard to determine. They're on the ground. We have the tripping hazard. We don't know what they're for, why, what's the application, what's the hose. You're just asking for trouble here. Cracked hose, bubble crimp. This is a very obvious steam hose. So a typical steam hose, that red and black version of a steam hose is obviously a steam fit hose with a universal fitting on there with one band. But in this particular occasion, this was a steam hose in a plant air application. Again, they ran out of air hose. So what they do? They grabbed a steam hose. Duct tape. Again, you don't need to be a seasoned pro to figure out this. Something wrong is happening underneath that hose. I don't know what it is, but I don't want to be there when they start using it. Another nitrogen hose, bubble crimp, universal is not pinned. This is a typical refinery drop, water, air, nitrogen, steam line. This nitrogen line was set aside for line dedication with blue spray paint, which is fine, I guess, assuming they always make sure that that's their nitrogen hose, but it's all the same universal hookup, so it could get tricky. Sample hose board. So this is one of the goals of a hose survey, is getting involved with that end user, writing the spec, setting up something like this. This is a sample hose board that we made for, I believe, a refinery in the Gulf. This shows what the air service fittings will look like, water, nitrogen drain, the steam service. There's a date punched for the date of the last test. This is also important, is to, when you're setting these specs up, hey, we want to change out the hoses every 12 months. We're at 8 months now. Might be time to think about some more steam hoses, air hoses, etc. But this is a great value-added service that we can create, make it specific for each end user. This is one of my favorites. So we have a steam line with a Chicago universal fitting, and again, when this is engaged, I don't want to be in this room. I want to get out of there. But it's pinned, so they did a good job there. Now, if you're using steam with a universal application, there's a very good chance that you'll be leaving the plant like this. Sad to say. But it's very dangerous out there, and especially in these critical applications, just some simple steam burns, getting electrical shock. It's all a part of probably a scary day for a lot of these operators. These are some common end user objections I've come across. I need to be able to field repair on my hoses. My guys are not comfortable using fill in the blank. I'm already using line dedicated hose system. My air hose is red, my water hose is blue, on and on. But what happens when you run out of red hose? My guys use a blue hose. Usually what happens. In conclusion, whether you offer a hose survey or if an end user requests it, it will be a really valuable exercise, only just for getting you more in good with your end user, because you can see what they're using, and then you could spread out into whatever else you may be selling inside of at an end user. If you're in response to an accident, you can highlight an error that was made and provide a solution. Simply a service you provide, you become indispensable for that customer. Prime benefit, of course, is helping the end user track these hoses. You can see a lot of these hoses, they keep in service. They don't know how long. After a while, you can't even read the ley lines. Who knows how long this stuff is in service? But that you can help track that. And then, of course, you can start selling some more hoses. So we have a little poll. Hold on, let me launch this poll. So there's some poll questions and then a couple general questions afterwards. All right. So good results so far. All right, let's close this bad boy up. So a universal fitting must A, have a locking pin, B, be crimped, C, have its bolts retorqued after every use. So this is A, have a locking pin. A universal fitting does not necessarily need to be crimped, and it's not necessarily going to have a bolt, those heavy type bolts that need to be retorqued. It's usually with a band clamp ball in there as well, or a crimp. But have a locking pin is the main thing, and especially what OSHA will be coming around looking for. And the next poll question. All right, I think we're all good on this one. What fitting is approved for steam service? 2% universe. Only a ground joint fitting, crimp steam type fitting. No cam and groove, no universals are acceptable in a steam application. Oops, let me share it. Okay. Sorry. All right. There we go. If a hose is damaged, but it's crimped, is that okay? And the answer is no. Whether it's crimped or clamped, the damaged hose will likely have a failure sooner than later. True or false, camber groove can be used in any application. We just got that as part of the poll question. That's false. Camber groove couplings must never be used for compressed gas or steam service. True or false, Campbell Fittings Universalock is rated to 300 PSI. That is true, as long as the assembly is Universalock by Universalock. And who is a leader in providing crimp solutions? As many of you know, that's Campbell Fittings, the leader in hose systems technology, member of the Ideal Tridon Group. And we're all finished. If anyone has any questions or chat, it's available now. Courtney, were there any questions?
We have one question. Where does the pin go on the universal?
There's a hole on either side that when they mate together, you'll see they'll line up exactly. I guess we didn't have a good picture of that, but I can certainly send everyone a picture of that. But there's a pretty defined hole for the locking clip.
Some other people are asking if they can get your slides after this. So yep, you can have the slides, and we'll also send you a recording of this webinar. That's it. If anyone has any other questions, you can send them in now.
Yeah, I'll email everybody later on that attended, and like I said, I'll certainly shoot you anything you need, and they can be sent separately as well.
All right, that looks like that's it for questions, Jeff.
Okay. Thank you, everyone. Appreciate the time, and we will be running this webinar next Monday as well. If you wanted to have anyone else check it out, I appreciate it. Thank you.